Thank you all so much for coming and giving me your time. I usually use the beginning of the presentation to get people to applause for everyone who's put in all the hard work on this conference. So if everyone doesn't mind, just a quick. Nice, and inside I just told myself you're clapping for me, so I feel really good right now. So this is the first slide I put on every presentation, and I do this kind of little mantra, and I turn towards the screen, and I look up and I put my hands and I just do this. And now I heard you laugh and I didn't see you and I'm like ready to go. I'm Myles. It's very nice to meet all of you. Thank you all so much for coming out and giving me your time. I really appreciate it. I currently work at a small disruptive startup cloud firm called IBM. It's worth mentioning the views in this talk are my own, although it is a lot of the work that I do for IBM. But anytime that I say anything that sounds like a personal opinion, it's probably mine. But so what exactly is CITGM? You probably saw that the talk is entitled the CITGM Diaries. So CITGM is an acronym, and it stands for Canary in the Gold Mine. And some of you may be thinking, well, it's actually Canary in the Coal Mine is the proper term. And the project was started and named by James Snell, who's my mentor at IBM. And I asked him this question and said, James, why did you call it Canary in the Gold Mine? And he just said it sounds good. So that's why. But what is it? Canary in the Gold Mine is a smoke testing utility that we use in the node.js project, primarily to make sure that we don't break your code. We don't want to break the ecosystem, and we want to make sure that it remains healthy. This is kind of the most important part. We release things via Semver, and we want to make sure that we are true to that contract. So Canary in the Gold Mine will go and it will grab the source code for a named module. It will run npm install, will run npm test, and then it will report the results. So it has a logger with various verbosity levels. On the top you can see the default verbosity of running a module called Oh My God I Pass. That's a module that I published. It has 0 code. npm test just does echo 0. It's really great if you want to test whether or not modules test suites pass. Below you can see it being run with a verbosity setting, and this is really great because it gives you more insight into all the network requests that are going on. If things aren't working, this is a great way to figure out why. It also has a variety of reporters that you can use. So if you're running a modules test suite and you want to report that onto GitHub or into some sort of blog or something, you can do output in Markdown. Here we can see the output for the module Oh My God I Fail. Version 2.02. The difference between Oh My God and Oh My God I Pass and Oh My God I Fail is that Oh My God I Fail echoes 1 instead of 0, and then it fails. You can report in tap as well. This is really great if you're running it in CI and you want to be able to use tools that consume tap, or if you have reporters that consume tap. And we also report in XUnit, and you may want to ask me, why, Myles? Why are you writing an XML reporter? And I wish I didn't have to, but it turns out that in Jenkins, if you're ever using the tap reporter in Jenkins, every time you load a page in the XML for Jenkins, it has all of the tap data, and it has to parse that tap data on every page load, and it doesn't cache it very nicely. And generally, for most test suites, this isn't a problem. But in Canary in the Gold Mine, after a run against 70 of the top modules, it's a lot of data, and that can actually cause 504 errors constantly from Jenkins, and our Jenkins instance running really slow. So we actually replaced the tap reporter with a XUnit reporter and used an off-the-shelf XUnit parser in Jenkins, and it just worked like way better. So CITGM All is also a utility that's available when you npm install Canary in the Gold Mine, and it will test 70 modules from the ecosystem. And we select these modules from a number of different places. This includes core ecosystem modules such as Request, Express, Body Parser, Graceful FS, Level, Async, WS, Socket.io, Serial Port, Lodash, and underscore. And you can't see it, and it's not because I don't like promises, but Q and Bluebird. This is a cropping issue. This was not intentional. We include modules for testing streams, including readable stream, through 2, split 2, duplexer 2, BL, binary split, SAX, duplexify, pumpify, and from 2. And we also include modules that you may not expect, such as ones for testing tooling and front-end frameworks. So we test Browserify, VinylFS, Gulp, React, jQuery, Node Sass, Ember CLI, Commander, Pug. And what's really interesting is that we've actually managed to get projects to simplify their workflow in order to get into Canary in the goldmine. Because really all it does is run npm install and npm test. So if you have anything special in your repo, such as a git submodule or something like that, sorry, I get like sick every time I think of them. But like we actually had Node Sass remove some git submodules that they had in order to get into our CI. So what's nice about this is it's starting to create a bit of a baseline within the ecosystem that people are adopting similar patterns for automating their test suites. But you can ask, exactly why are we doing this? And it's because every test in the Node.js ecosystem is actually an integration test for core. This is really, really interesting. As all of you probably know, there are so many edge cases that are out there. You can't even think of all the ways that things can break because the universe just has it out for you. But what we can do is we can rely on all the edge cases that other people are writing for their own code, and we can know, hey, if in the latest version of Node, these tests were passing, and in the new version that we're about to cut, it's breaking, we know we changed something. And then we have enough information to do a deep dive and find the breaking difference. I don't know how many of you often use Git. God, why am I totally spacing on my favorite Git utility? It's a binary parse that allows you to go through. Can someone scream it out because they know what I'm talking about? Thank you. So I don't know if anyone uses git bisect at all. It's like one of my favorite tools. But if you know where code was working and you know a place where code was broken, you can use git bisect to do a binary search against the entire tree and find the offending commit. So the great thing about a tool like this is we can find when we did something that broke it. I can write like a 5-line shell script to automate running the test suites of a module, and then I can just do git bisect good in the good commit, git bisect bad in the bad commit, git bisect run in the script, and it will, as long as it takes to run the test suite, eventually tell me, hey, this is the commit that broke things. And then we can go in and do deeper introspective into, hey, did we mean to break it? Is this actually breaking? And it really helps us to remain stable and not break your code. So what's great is we can actually find out what's going to break before it breaks. By landing things on master as quickly as we do, we have the ability to precog, to figure out what we're going to break before we release. So as I was saying, we run Canary in the goldmine in CI, and it's actually now mandatory that the Canary in the goldmine be passing for any Semver major changes or for releases. And for changes in which we're not sure whether or not they're breaking, we'll make it actually like a passing step as well. So if you're making a change to streams, and it may not be Semver major, but we're kind of like, oh, streams are kind of fragile, like we'll actually run it through the test suite and make sure that it's working. You'll see down here some of the operating systems that we run the test suite on. It's not as full of a suite as the Node CI is run on, but we're still running on Debian, 2 versions of Fedora, OS X, a couple versions of Ubuntu. So we have a decent amount of spread. And it's really interesting, some of the errors that we find, because what may work on BSD may not work on Fedora or may not work on Ubuntu. We actually had an issue a while ago with RealPath where the RealPath implementation in BSD actually didn't include limits by default, so it was actually causing some like really weird errors, but it was like only in the stdlib of BSD. So if we weren't testing all of these, we wouldn't have seen it. It's really interesting, to be forced to dig into kernel code. But how does it work? And that's a good question. How do we do this? It's actually not as complicated as you might think. We actually just do a lot of wrapping. So npm view, we wrap that. We use npm view. You do npm view and then the name of a module, and it will give you back a JSON file with all the information about that module, what the latest tarball is, what the repo is, who the author's name is. That's part of like essentially npm's lifecycle. So if you want to get information about a module, you can use that command. npm pack, we wrap that. npm pack, if you say npm pack and a module name, it will actually just give you the tarball for that module. If you do npm pack and a link to a Git repo, it will give you the tarball from GitHub, which may have more data in it than you will in just the modules on NPM. So actually in Canary in the goldmine, we're generally grabbing tarballs from GitHub rather than from NPM, because not everyone publishes with all their tests and everything. npm install, we wrap that. You can imagine we want to grab the module. We have the module. It's untarred. We run npm install, and then it's ready to be run. npm test. We wrap that. This is my favorite one. It's called the pupper burrito. I know. But yeah, you may be thinking to yourself, why, oh, why are you using a child processes constantly to call out to a CLI? Is there not an API you could be using? And it turns out that NPM already does all of this stuff. And every build that we do in CI already comes with NPM installed as a binary that we can call to. And another thing that's really nice is that the NPM CLI is managed by Semver, and it's a Semver that we actually as a project have somewhat of a control on. If you actually go to the NPM website and look up the documentation to try to find documentation about whether or not you can use NPM as an API, you won't find any. And I may be incorrect in this, but the last time I checked, NPM does not officially support NPM itself being required and being used programmatically. So part of the reason why we're wrapping everything in child processes is because NPM is supported as a CLI utility. So we're guaranteed to have consistent support as long as we do it that way. So when we have it all wrapped, we're taking all the std out messages, all the std messages, we're managing them, we're piping them around, we're keeping track of that, we're keeping track of which modules passed, which modules failed. We have a lookup table that also includes which modules are flaky, what systems they're flaky on. We have a little grammar built in there. So you could say, hey, request is flaky, but only on PowerPC because it uses ESLint, and ESLint requires Phantom.js. Like, there's all these weird edge cases. But we have a grammar that we can use so that we know, hey, these particular modules are flaky on these particular architectures or these particular operating systems. And that's what the reporters will show at the end, is a report of, hey, here's the things that are working, here's the things that are broken, and here are the things that we expected to be broken. So let's talk a little bit about things that have broken. Dear diary, today we broke NPM. This is what it felt like. Everything's falling around. So it turns out that there was an API that was deprecated in 2010, but was never actually deprecated. They forgot it, I guess, and then no one ever really checked. But it was the string interface on FS read. And it just seemed like a general thing that we should do is, hey, maybe we should actually deprecate that API. In the deprecation process, the first thing we do is emit warning messages because they are less detrimental to the stack than just making something not useful anymore. And we could see here, this was essentially the code. And you can't tell too much, but there's a require here to an internal util called print deprecation message. And then when that API is used and the thing that's passed is a string, we print the deprecation. It's pretty straightforward. The print deprecation method has the ability to know whether it's been called or not, so it's not called multiple times. And there's also hooks now into the node lifecycle. You can run node with, I think it's like I forget the exact phrase, but it's like stack trace deprecation or stack trace warning or like throw warning. And so every time you hit a warning, we'll actually print a stack trace for you, and that's really good for chasing down the warnings you have in your stack. And as long as you're using this API, we're guaranteed that those warning messages kind of hook into these lifecycle events. So we weren't really expecting much. It got reviewed, it got landed. This was all pretty rote until it broke NPM on master. So Canary in the goldmine, I went to run it one day, and it just didn't. One of the first steps we do is actually npm install Canary in the goldmine before we run Canary in the goldmine, and that didn't work. And so, I ran the test suite, I went and did something for 30 minutes, and I went to go check back, and everything was red, and I was scared. So, the commit broke npm and master, and to reproduce, simply run npm install. The good news was that we didn't break npm substack, npm visnup, or npm xmis, which are all awesome Easter eggs, but it's probably a good idea not to have a broken npm on master. So why did it break? And this was really interesting. It actually had to do with the way in which Graceful FS works. Can I see a show of hands of how many people know what Graceful FS is? Okay, cool. So I'll spend a little bit more time on that. Graceful FS is a module that was written by Isaacs, and it's a wrapper around the FS module that just is more graceful. Ways in which the FS module will throw or cause problems, Graceful FS will just be like, okay, it's cool. Just keep doing it. I know there's an error. And it just makes things a lot less painful. Can I see a show of hands? How many people have used Gulp before? So a few more. So Gulp is built on top of a utility called Vinyl FS. Vinyl FS is an abstraction for doing stream-based stuff over the file system. Like pretty much any time you do like Gulp source pipe, that's just an abstraction over Vinyl FS. And so Vinyl FS under the hood is actually using Graceful FS for all of its calls. So you can maybe get an idea of where this is going. But for now, we're focusing on NPM. And it turned out that NPM had a module called Command Shim inside. And inside of Command Shim, they were following an old version of Graceful FS version 3. In Graceful FS version 3, unfortunately what was happening was Graceful FS was using the VM module. It was using an undocumented feature, which is process.bindings, to get the source code of FS. It was then executing that source code inside a VM and then doing all sorts of little hooks into it to be more graceful, and then exposing that version that was in the VM to userland. And so what this allowed it to do is it allowed it to monkey patch FS without monkey patching over the FS that Node would use internally. This is important to do because if you're going to monkey patch something like that, you could end up breaking all of Node. So this kind of contained it. The unexpected problem was that when we included an internal module, which anything in internal is actually not able to be required from userland without a flag, everything explodes because it can't find it. And this was actually something that was a problem 6 months prior to this. And they actually rewrote a new version of Graceful FS, Graceful FS 4, that fixed this around the time that this hit us the first time. And most of the things in NPM were updated, but it turned out, you know, this one package had this dependency that hadn't been caught yet. So a short-term solution was made, and essentially what we did was we went and grabbed what was in internal util print deprecation method and just plopped it right in there as a temporary solution for V5. And the idea is we were going to land this in now, and then for V7 as a major change, we're going to revert it. This allowed us to move forward with actually deprecating in a way where we warned it to people. You can see down here we have a print deprecation message, and that's great. We were able to do it. And so there was no way that we were able to know right away that a warning would break the world. And what was really great is because we had Canary in the goldmine to catch this, we were able to catch that NPM was broken. If we had not caught that, if we had not done enough due diligence, it would have been possible that we could have cut a release with a broken NPM. That would have been miserable. Trying to get people to install it, and once you release a version of software, you never know how many people are going to install it forever. It's the weirdest thing. People will show up and be like, I'm running node 573, and I installed it yesterday. And you're like, where did you find that? And I don't mean that as any insult or attack on the person. It's more just literally, where did you find it? I'm very interested to find out because I don't know. But this happens. So when you release software, when you release broken software, that's in the ecosystem. That's going to break lots of people and confuse lots of people. So it's really good to catch that. So we ended up, the way we solved that afterwards is we also wrote a new unit test for NPM that was able to test whether or not NPM install worked, and it was just a no-op. And so now every time we run our test suite, it does a little no-op NPM install, and if we ever break NPM again, we'll know. And that's the best way to handle it when you break software, because you're going to break software, just don't break it twice. So dear diary, today we broke body parser. How many people know body parser? Okay, so how many people know Express? So body parser is what's used in Express to parse bodies. So this is extremely hot code, and that's why there's fire all over the screen. Body parser is run in Express, and some examples of the scale of that is Kraken is built on top of Express over at PayPal. A whole bunch of PayPal's infrastructure is running on that. Strong loops, loopback utilities, all built on top of Express. So breaking body parser is going to break a lot of the internet. So how do we break it? In a completely unexpected and beautiful way. Query string.parse. Also, again, code that's probably used a lot. Very hot code. Lots of query strings being parsed. There was logic inside of query string that was deemed unnecessary. Essentially, we were calling string.split on a string of a query string, and it was creating a large array. And then if someone gave max keys as a value, we were comparing the length of that array to the max keys, and then dumping a bunch of memory, just shortening the array. And this creates a whole bunch of unnecessary garbage, and especially in really, really hot code, such as query string parse, because it's being run in all of this stuff, that can actually have huge performance degradation or create all sorts of extra garbage. So it was a very, very minimal change, went through really quickly as a patch, and all it did was pass max key as the second argument to split, because it turns out split actually has an argument, a second argument, that you can do this. So yay, no more garbage. Things are faster. But one thing we didn't think about was infinity. And whenever you're dealing with infinity, your life is going to be difficult. But before we did this change, query string.parse, parsing a string with one query string in it, with a max key set to infinity, would give back a length of 1, as one would expect. After the change, it gave back a length of 0, which is not what you would expect. Why did that happen? Well, it turns out that the second argument to split is expecting an integer. Now, I'll ignore the fact that integers don't exist in JavaScript, but it means that in the VM it's inferred as an integer. When infinity is inferred as an integer, it's inferred as 0, because mathematically that's correct. I would argue logically infinity is 1, but we don't need to have that argument. This is the spec. This is what we live by. These are the rules of our universe. So when max keys was put there as the argument to split, it was always passing 0. Now in Node Core, we didn't have a test to test for infinity, but Body Parser had that extra edge case because Doug Wilson is amazing and thinks of everything. And so it was actually pretty straightforward. Once we saw it was broken, we could go and we just wrote a test using the vanilla assert, and then the change to fix it was pretty straightforward. It was literally just checking for infinity. But sometimes a patch is much more disruptive than it seems at first. And this is why these kinds of tools are really important. We don't know everything. We don't know everything about these systems and all the weird ways that they interact. And there's no way that we can. The only thing that we can do is create systems in which we can minimize the damage. Dear Diary, today we accidentally broke Gulp. So remember how I was talking about how in Node 7 we were going to revert that change that broke Graceful FS? Well, we did, or we tried to. And you can see the change here. It was literally just grabbing all that code that we added before and adding back that internal module. Seems pretty painless. We gave the ecosystem a bunch of time. It was no longer breaking NPM. We thought everything was going to be fine. And then we ran Canary in the gold mine. And it turned out a lot of stuff broke. So we ended up having Chalker, who's a member of Node Core. He does really, really amazing work right now on ecosystem analysis. So he has these databases of, or like, I think they're just like giant archives of like all the strings of all the modules, of all of the code in all the modules. And he has these regular expressions that go through and can find like all the instances of requiring specific modules. So if we wanted to know in the entire ecosystem, how many modules are there that are actually still using Graceful FS 3? Because we knew that if we landed this change, we would just break all of those. Like not even just a little bit, just all that code would stop working. And it turned out that still 5% of NPM, 5% of the modules on the planet still use this code. So this is bad. We started using internal modules for various things. And one of the things we wanted to use it in FS4 was for abstracting errors. As it is right now, error messages are semver major changes. We want to make it so that there's error codes that we can give instead, and that the message would be in a lookup table based on the error code and the specific message that's being thrown. This would allow for internationalized error messages. It would allow us to modify error messages without it being semver major. This is something that James Snell is moving forward with right now. But this blocked that work. If we can't even just land this message that emits a warning because we're going to break 5% of the ecosystem, how are we ever going to get to that code? And there are a handful of other efforts that all got jammed on SF. So we dug in more. And it turns out that we were able to get the list down quite a bit. You can see the dates here and the number of modules that between May 20th and June 6th, it's almost half the size. We got it down to about 60% of the original by sending out just tons of pull requests to modules in the ecosystem. But there was one module that wasn't updated, and that was Gulp 3. And as many of you had your hands raised because you've used Gulp before, you know how proliferated that is in our ecosystem. So under the hood, Gulp 3 is using VinylFS 0.5.x. VinylFS 0.5.x is using Graceful FS version 3. Because of how complicated the system of Gulp is, the maintainers of Gulp felt completely uncomfortable just arbitrarily bumping the version of Vinyl FS. Because they couldn't bump Vinyl FS, we were unable to bump Graceful FS. We even tried to bump Graceful FS in a way that, like, to bump Graceful FS in Vinyl FS, but it still was something that Gulp 3 didn't have the kind of test suite that would allow us to do it in a safe way. So what ended up happening there was we had to try to figure out, well, can we fix Vinyl FS? Oh yeah, and so 28% of the modules that were left directly, and 42% of the ones indirectly that were broken were all related to Gulp. So this is one of those things that if we ship this code, we would break all of Gulp in version 7. And this is actually something to be taken really seriously, and I'll caveat this by saying this is not saying ill of anyone who's using Gulp, but many of the people who are Gulp users are not necessarily Node developers. And I mean that in the sense that they are not writing Node servers every day. They're not necessarily super familiar with the Node ecosystem and how to solve these problems. So if you're a user if you're an individual working as a front-end developer or just trying to install WordPress and Gulp is sitting somewhere in your stack and all of a sudden everything blows up one day, you don't really know how to deal with this. And that's really, really irresponsible for us to do. So to avoid breaking the world, I did a little reggae. And doing regexes now are called reggaes due to a spelling error that I made accidentally once. Isaac's really enjoyed it, and so yeah, anytime you do a regex, it's doing a reggae. And basically what we did was, you're gonna recognize this code. We took that chunk of code that we had just hard-coded into Node before, and we did a little reggae, and we found any time where we were requiring the internal module, we'll just drop that right in there. And we released that as a patch onto version 3 of Graceful FS. And the nice effect of this is that all of the modules that were affected by that are now no longer broken, except that they still were. Because it turned out that there's a whole bunch of other things that we're working on, as I was saying, like the error messages, that will break this again later. So this Band-Aid wasn't really going to solve the problem. So we almost gave up. We almost actually came to the conclusion that as much as we would like to move forward here with this, we can't afford to break this much of the ecosystem. And we decided at first that we weren't actually going to move forward with it in Node 7, which meant that a whole bunch of work that we wanted to do improving FS was going to get pushed possibly all the way until Node 8 or Node 9 before it would even land, because if we land things in 8, it's a lot harder to revert it before it goes LTS. So it was really important for us to try to land this in 7 because it's experimental. Until Isaac came up with an extremely elegant solution. He updated Graceful FS 3, and we were able to land it. What he landed was this new module he created called Natives. And Natives is a module that allows him to require in and run the code in a VM that explicitly find the times where there's internal modules and flip the flag that's necessary to grab internal modules, but only in the VM. It's just like all this like craziness. But with all those things that are moving around, he was able to get it set up in a way where things didn't break and the universe didn't explode. This is an example of how you can use it. You say var natives equals require natives, fs code equals natives.sourcefs, and that will give you the source of fs. And you can assert and require, and it allows him to do what was trying to be done before. But one thing I will mention, if you take a look at the note, I feel compelled to give you a word of warning if you were considering using this module. It lets you do some creative things with JavaScript code in Node. There are some things here that are basically a recipe for memory leaks, or at the very least being broken with each new release of Node, since none of these API surfaces are technically supported by the team managing the project. So I just wanted to make sure you all have the caveat. Be careful of using this module if you're thinking about it. It was for a very explicit purpose to stop the universe from being destroyed. But what's interesting, we learned from this, and as of Node 7, we actually are taking out all of the parts where we did a print deprecation warning, and now we're actually just emitting warnings with a specific flag, so there's no need to do any sort of requiring of internal modules. So, like, we're willing to listen and bend on both sides and find a place that just, makes things easier for everyone. So, dear diary, even though we broke a lot of stuff, most people didn't notice. And that's a reason to celebrate in my mind. So thank you very much. This is a picture of Jean-Luc Picard playing a flute.